So today I'm going to do a little talk on Kubernetes. How many people know what Kubernetes is? I've heard of it.
Yes.
Yeah. Okay. Yeah, Dave, I expect you have. Nick, have you heard of it?
Yes, it's something to do with cigars.
Yeah, that's right. What is Kubernetes? It's a portable container orchestration system. You might say, what the hell does that mean? So you can look at it as like a nice, cozy home to run your containerized cloud-native apps. And again, there's lots of, jargon in there. It's an excellent fit for microservices architecture. It allows you to grow and shrink your resources as you require them, and it allows you to do lots of cool things. It's widely adopted by cloud computing providers. So because it's portable, you can write Kubernetes to run in any location. Kubernetes actually describes itself as a platform for automating deployment, scaling, and operations of application containers across clusters of hosts. And I'll get more into that later. It supports both automated and declarative management. So that allows you to adjust things on the fly, or allows you to execute config files, which then get persisted, and Kubernetes reconciles itself and brings it up to the desired state, which is really cool. It's consistent across development, testing, and production. It takes the concept of containers, container technologies such as Docker, which is by far and away the most popular, and allows you to dictate the environment which your applications and their dependencies run. So just a brief history. So this is like three different phases of hosting, particularly web apps. But it is applicable even pre-web as well. So on the left, you've got like the traditional deployment where there's only three layers, and then the application layer, the operating system, and the hardware. If you need new hardware, then you need to do nasty things like procurement, and you need to get it signed off, and it takes a very long time. It's quite error prone, and it's just really old school. It doesn't fit architecture anymore of the way web applications typically are built. Virtualization came along next, and it was a massive revolution in the fact that you could spin up, tear down your machines as and when you needed them, and lots of providers provided APIs to allow you to spin up new dependencies and application environments as you need them. Unfortunately, there was it was a bit of the Wild West, and each provider originally ran its own systems, which are not necessarily compatible with each other. Great steps were made later on, but it still had its problems. Then containerization was another kind of quantum leap forward in the fact that you bundled everything that you needed for your environment in a container. There are plenty of container technologies out there. Obviously, as previously mentioned, Docker is by far the biggest, but you've also got things like Containerd and RXT, I think it is, which I don't know very much about either of the second two. But it allowed, it was a quantum leap forward because you could take your environment that you're using in development and then eventually use it in testing and production. So a container orchestrator is something that allows you to operate and manage your containers and your architecture in a consistent way with powerful tools, and it allows you to be just extremely flexible. It's containers on steroids. It's really quite exciting. So the word Kubernetes is Greek for helmsman. Apparently it's got lots of other meanings as well, but that's the meaning that why Kubernetes named itself, because it navigates containers for you. It's a project started by Google in 2014. It shares, so Kubernetes actually shares a lot of the same team that developed Google's in-house container orchestration system called Borg. It allowed them to manage literally millions of containers, which is really powerful. But it was never available commercially, or it was always in-house. The code name for Kubernetes when it's been developed was 7, and that was a reference to the Starship Voyager character 7 and 9, who's an ex-member of the Borg, and there she is there. Obviously, it wouldn't be able to call it 7 of 9, so they have a little nod to it. So the 7 spokes of the wheel in the logo is a reference to that, which obviously is amazing. So how do I get it? There's lots of ways of getting it. The 3 kind of probably best ways of getting it. All the big cloud computing companies offer a flavor of Kubernetes. There's links there. I'm not sure everyone gets them. But basically cloud, because it's so ubiquitous now, all cloud providers provide Kubernetes basically. You can also run it locally. Docker Desktop bundles it just 2 clicks away for you. So it's pretty cool. It's a single node, and I'll get onto what that means later. There's also a playground, Play with Kubernetes, which you just point your browser to, and it gives you a Kubernetes cluster, which expires and is teared down after 4 hours. So it allows you to test and play with your configurations before committing to any paid-for services. So how does it work? So a Kubernetes installation is known as a cluster. So it's basically kind of like akin to a virtual private network, I guess it's fairly similar to. A cluster is made up of one or more nodes, and a node is made up of one or more Kubernetes objects. So what are Kubernetes objects? Well, there is lots of them. So they range from quite generic to extremely specialized. So containers are synonymous with Kubernetes, such as Docker containers, but that can be other container technologies as well. Kubernetes does not run containers directly, not at least. Sorry, tying up my tongue. So if you consider for virtualization, the atomic unit is the VM. The atomic unit for Kubernetes is the pod. So a pod wraps one more containers which run your code. A pod is Kubernetes primitive, a Kubernetes objects, and it's one of many different types. And it's unspecialized primitive. It doesn't do a lot on its own. It's simply a building block. So these are some of the popular Kubernetes objects. So you've got pods that previously discussed. Deployments wrap pods and allow for things like scaling and rolling updates, allow you to expand and contract the amount of pods that you run. It also allows you to expand and contract the resources that the pods have. So it allows scaling both horizontally and vertically. So you've got a daemon sets. I'm not that familiar with them, to tell you the truth, but it's used in making sure that service is always running. You've got stateful sets. So Kubernetes objects, by their nature, are ephemeral. You don't really want to store data on them. You want to connect other services to your pods to do the storage for you, because of the idea is that you spin them up and roll them down as you need them. And you've got replica sets, which do similar things to daemon sets. So you've got services, which represent how the networks work within your cluster. There's lots of different types, so I'll be showing you two later on. You've got volumes, persistent volumes, and persistent volume claims. They are obviously, as you might guess, they persist data for you, and you attach them to pods. You've got secrets for managing sensitive information between Kubernetes objects. You've got cron jobs to make sure that things run on time and when you expect them. Jobs I'm not that familiar with, but I believe they do a similar thing. You've got HPA and quotas. They're both used in scaling. And then you've got a couple of other things like users and roles, which dictate security. I'm sorry, I can't see the screen, so there's one more, I think. Sorry, didn't need to do that. Apologies. To go through it again. So, how to work it? So, I'll tell you a little bit of the design, and then I'll tell you a little bit about the tools. So, someone has a business idea, you know, we're all familiar with this, and that business idea requires a website or web application. They consult a knowledgeable agency such as Kyan, and they want to deploy the application with Kubernetes, maybe like a Rails app with a Postgres backend. So traditionally, you know, the architecture will be sketched out in such a way, you know, so you've got a server running Rails. You might want some redundancy, so you know you have 3 replicas. That dictates that requires a load balancer to balance it across it. Obviously, the back end is Postgres, as you already discussed. You probably want to take care to make sure that your data is safe, so you add a persistent volume to it. You know, you mount a volume to it somehow, and then you want to secure it. You want the comms between the web servers and the database to, you know, you want to encrypt the credentials, basically. So you start mapping these to Kubernetes objects. So you probably have a pod running in each of the web servers that would run one or more containers that are running your code. Then you want a load balancer. So SVC is a service. A load balancer is a type of service, which would balance the requests across all 3. You got a pod for the database, and then you've got a persistent volume and a persistent volume claim. So the persistent volume is, as you would expect, it's like a hard drive. The persistent volume claim is like a ticket to that volume. So you want to store your Postgres database on that. And then you've got a specialized secrets object, which will contain information to, you know, to keep the credentials safe. So if we take the original objects away, that's what we're left with. So this is kind of, we're starting to get an idea of what our cluster might look like. So Kubernetes is built in a way that certain objects will actually talk to the cloud provider's backend to provision certain objects for that Kubernetes object. So in this case, it would spin up a load balancer, and you know, in those 3 different, you know, in your cloud provider's own API. The same is true for persistent volumes. So it will provision the type and the amount of storage that you need on its backend systems. So we have a a quick demo, and this is hopefully going to go well. I've got two demos for you. So I'm going to show you using Docker's local development environment and the Kubernetes install. And I will quickly show you a Google Kubernetes engine example. Both are very similar. Please bear in mind that obviously these are not production ready. I've kind of designed it in such a way to kind of show some of the features of Kubernetes rather than the actual finished product itself. So what we're going to do, we're going to build an extremely simple Ruby on Rails website with a Docker file. We're then going to build a custom image using the code and the Docker file. We're going to push the built image to publicly accessible image repository. In this case, it's going to be Docker Hub. We're going to configure the Kubernetes cluster or its clusters and tools to allow us to talk and deploy stuff. We're going to build the Kubernetes objects that we require, as dictated by the schematic I just showed you. We're going to use Kubernetes supplies a command line app called kubectl, and we're going to use it to both apply the configs and then interrogate the configs afterwards. Unfortunately, we don't have time to do. Unfortunately, they take those top three things actually take quite a long time to do. So I had done them prior to this. So I'll show you what I've done, but I'm not going to make you sit there and wait 10, 15 minutes while an image builds. So, let's go to the demo. I've got two GitHub repositories, one with the application code and one with the Kubernetes configs. Because the actual result is going to be slightly different, I've divided them into two directories. We'll start with the local config first. So I've got 4 Kubernetes config files here. As you can see, they're in YAML. They're reasonably easy to read. So the first one is the secrets. This is a requirement of both the database and the web, so I thought I would do it first. So it's declarative, as you can see. So this is just contains one. It's basically a key value store. And it contains one key, which is going to be a database password. This value here is the result of running this command. So basically, it takes this string and passes it to base 64, and the result is this string here. It's not top grade security by any means, so please don't do this in production. Then we're going to move on to the database pod, which is somewhat bigger. So each, the triple dash divides the Kubernetes objects. So we're going to create a service to allow public traffic to reach our Kubernetes cluster. We're going to call it DB for database, and I'll go onto labels later on. It's going to be, we're going to have it a label of app, and the values will be web. This is some of the specifications. This is the default Kubernetes port, and these again these selectors tie themselves to the labels. This is a cluster IP, which is none. can't remember what a cluster IP does off the top of my head, so I'm sure Nick can fill us in at some point. We then move on to the persistent volume claim. So the persistent volume claim, this is like a ticket to a persistent volume, which is where you store your data. Similar type of thing. You give it a name, you give it a label, you give it like access mode and the resources that we need. In this case, it's going to be a 2 gig volume. So this will try to match itself to a free persistent volume. If it doesn't find one, it will generate one on the fly for us, which is exactly what we want. So we'll allow it to do that. We then move on to the deployment. So this is probably a little bit unnecessary. That's a little bit closer to real world. In theory, this could just be a pod, but I've chosen to put it into a deployment just because that's what you do in the real world. It's a little bit closer to reality. So we go onto the template. It's got the labels, which we're quite familiar with now. And the specifications, this is a list of containers that are going to run inside that pod. In this case, it's only one. The image we're going to use is the stock official Postgres 12 image. We're going to name it DB. We're then going to set an environment variable, which is a requirement of Postgres. And we're going to set the value from the secret that we created earlier. And the key to that secret is going to be the database password. So that allows us that allows us to set up the credentials. We've also got PG data, which tells Postgres where to save its data, and that maps to the volumes, the storage volumes that I'll show in just a second. It then exposes some ports, and it's going to call that port DB. So that's your default. Postgres port. So the resources are what resources the container runs. So in this case, it's going to be 256 megabytes of RAM. What's the M stand for, Nick? Can you remember? For the CPU?
It's a good question. I don't know.
It's milli something. I can't remember what it is. Sorry. I'll try and find out for you. So that is basically half of the CPU available in the pod. So if there's obviously 2 containers, then that's obviously the resources will be 100%. These are volume mount paths. This just sets up the persistent volume that we looked at earlier. And that is more information for that down there. So the PV claim matches the PV claim here. Web is fairly similar, but a little less complicated. So this, again, it's a deployment. It's just got one container. The interesting thing is this. So this is an image that I've created, and it's available on Docker Hub. So obviously that's my username, and I called it dev talk, and the tag I've used is 0.7. That obviously incremented as I was developing it. We're called the container web. We also need to know what the Postgres password is. And again, that takes that from the secret, with the key in the secret is DB password. We then expose ports, and these are resources that the pods contain, require. These are lower, obviously. So obviously this is a quarter of the CPU this time. So the final bit is the service itself. So this is just, this isn't a load balancer. It's much cruder than that. So basically all it does is it exposes a port and then pushes it to another port. And it's got a selection of web. So I'm now going to apply those. So I'm going to check that I'm in the correct Kubernetes context, which I am, which is Docker desktop. So we're going to use the kubectl command line tool to apply those configurations. We'll do them consecutively. So we'll do, so local is the directory here. We'll start with the secret. So I'm going to use kubectl to interrogate that secret. So that tells you that the default type is opaque, and the secret is there, and it's got the key that we're required to pass to the two different pods. We then apply the next one, which is the DB. So this takes a little bit longer because it's doing a lot more. So kubectl, again, we can use to interrogate the pods. We'll stick a watch command to watch it. Okay, so because it's already got the image locally cached, it's spun up incredibly quickly. I think the same is going to be true for our web pods as well. So there you go. So it's already spun that up for us. Okay, then we need to apply the node port. So internally, we got something called a cluster IP for the DB to allow it to always be in the same place. This node port, it exposes port 31,000 and pushes it to the internal port of 3,000. We've got to set up the Rails app now because obviously the database and the seeds haven't run yet. So we're going to run bin setup, which you get with Rails apps these days. So first we need to get the ID of the pod for the web, which is that one. And we will run kubectl exec, paste that, and then the command itself, which is bin setup. So that's installing the dependencies, checking the gem file, yarn, prepping the database, creating the database, tidying some stuff up, restarting the server. So, all being equal, you should be able to see that localhost 31,000. Eventually. There you go. So the seed file was just 3 entries into the database, and then it just goes through them, loops through them. So as you can see, it's extremely cutting edge and very beautiful. I'm not going to go into so much detail with the Google Cloud version. I'll just show you the differences between the Kubernetes configs. So I won't bore you too much, but just go to our cluster. So we're going to create a cluster, standard config. Call it dev talk. We put it in Europe, London in particular. and we'll leave everything else as default. So this takes a while to set it up. So what we'll do, Google's got this really cool tool for allowing you to set up the cluster, to configure kubectl to use the cluster locally. So we'll do that while we wait. Gcloud is, oh, hang on. Okay, it's still provisioning, so just give it a couple of seconds. Google Cloud offers their own command line tools, which is Gcloud. I've got this configured because we use it in Stonehaven. There you go. So it's done. And then kubectl config, get context. So these are my two Stonehaven ones. This is the local desktop one, which we've just been using. And this is the new one. Obviously, that's an ugly name. So we can rename that. Call it DevTalk GCP, sounds good. So this now tells us that we're on the correct, so we're administering the correct cluster. While that's running, I'll show you the differences. So the secret's exactly the same. The database is exactly the same. The web is, hang on, I'm looking at the wrong one. The web is our first difference. So in this case, we're actually going to have 3 replicas. So 3 lots of this pod are going to get created. Everything else is the same. I've downed the CPU a little bit. The load balancer is different. So where we created a node port for our local version, I'm creating a load balancer for this one. So that uses the correct HTTP port and it pushes it to port 3000, which is what the containers are listening on. We'll have a quick look at it's still provisioning. Give that a couple of minutes. Does anyone want to ask any questions just while we wait for that? No?
Steve, I had a little question.
Go
on. In your excellent cliffhanger demo there, whilst we were waiting for it all to magically spin into life, yep. Obviously you proved how nicely it plays with Docker. Yep. Did you use Docker there just for familiarity's sake? Because you could have used pure Kubernetes for all of those processes, couldn't you?
So Kubernetes isn't a container system itself. It indirectly runs other container technologies. So to answer your question, yes, I use Docker because of the familiarity with it, for sure. But it could be any number of container technologies. I've never done it. I've never even tried to, but Kubernetes can also run virtual machines and what's the word? Cloud functions as well, apparently. But I've never done it. Does that answer your question, yeah?
Yeah, that makes sense. I was under the impression that Kubernetes had those sort of local containerization aspects as well, but it doesn't. That's good to know.
Yeah. Okay. So Kubernetes runs something called CRI, which is a common interface for containers to run against. I think it's Container Runtime Interface. I think it's short for, and I think all of the major container systems now have adopted it. There's a list there. which I'll share later on, which goes through some container runtimes, a lot of which I've never heard of. So, any more questions before I go back to the demo?
I've got one.
Go on.
So what you just demoed there, you pulled the Rails app from like a pre-built image, right? Your Wakey. Like if something like a Heroku deployment, or even what we do with Docker Compose, typically we kind of build out the app from a Docker file or from a repo spec as part of that process. In like a production environment like you have on Stonehaven, is Kubernetes what runs the CI to actually do the deploy, and is it doing the build then? Or do you have these kind of two separate things where you build out your application images and then you have a Kubernetes pipeline separate that actually does the deployment of that?
So they're all separate, but they're all linked together. So Google Cloud has got two other services that we use in Stonehaven. One of them is an image repository, like Docker Hub, where it's a private repository for you to pull your images from. It's also got, I think it's called Cloud Build. So when a PR is merged in GitHub, it fires off the Cloud Build. It goes and fetches the new code and then builds it from the Docker file. Something I actually skipped, I'm afraid, but I'll quickly show you. So to take the Docker file and the Rails files, I built it with Docker's tools. So they look like this. So Docker image build, and then that's the T is target, and so that's username, name of the app, tag, and the dot at the end means all current files. So obviously that's just your default relative path. Then you use Docker to push it to the image, push the image to its own repository. In this case, it's Docker Hub. So those are the two missing steps. Unfortunately, this takes 10 minutes, and this on my internet connection takes forever, unfortunately. So I wasn't able to demo it.
Yeah, that makes sense. Thanks.
Okay. So we've now got it built. So our cluster now exists, and we got it configured. So it's just a case of us now applying those commands to that cluster. So kube CTL. Let's move you guys on here. Oh. So it's very much the same process. I think it might take longer though, because of we're on a fresh cluster, so I doubt it's got the images cached now. So then if we use the tool to get pods, and we'll watch it. Just wait a couple of seconds to see if it's behaving. Did it quite quickly earlier. Is there any other questions while we sit and stare at that?
I've got a couple of questions.
Go on.
I don't. So it's yeah. Well, first of all, this is great, Wakey, because I think it's showing a lot of. It's quite a complicated subject, Kubernetes, isn't it? There's a lot of moving parts, basically. I wonder how much of this can be. So for Stonehaven, obviously, I guess you're using this technology, and it seems like it's a sensible option with I guess I know Nick was looking at Argo CD, which is another layer on top of this, isn't it? Which kind of orchestrates Kubernetes. I think it allows you to kind of easily deploy stuff or see stuff running. But in general, how easy is this? How repeatable is this? I mean, because there's a lot of moving parts. Is there a layer on top that makes a lot of this configuration repeatable? So you could easily do it for another project, or do you think everything is kind of hand cranked?
So yeah, it's you can certainly build. It's very complicated, as you say, and Nick worked extremely hard with things like the Docker files to create the images required for our pods. I think it is very repeatable. You could certainly start templating it to a certain degree. The administration that I've shown you in the demos, obviously you tend to do that infrequently, and you just if you've got a new version of the image, for example, you update it, apply it, and then it goes off and does its stuff. Also, I've skimmed over a lot of the detail, I'm afraid, for the sake of brevity. I'm not sure that answers your question, really, Duncan.
No, that's fair. I guess the other simple question is, like, are you still using traditional Docker Compose commands in development, or are you using Kubernetes locally to do development?
So we are still using Docker Compose.
Okay.
We have considered it, and I think we're probably maybe one day we might move over to Kubernetes, but it doesn't seem to offer many advantages right now, apart from similarity in environments. Obviously, the development environments have got a lot more tools, which you wouldn't want on a production version as well. So that further complicates things.
If it's any consolation, so Quanto quite heavily use Kubernetes,
right?
Way beyond what I would understand. It's proper, it feels like it's dedicated sysadmin knowledge, and they use Docker Compose locally for their development environment.
I see.
They haven't, so it's for similar reasoning. It's just too complicated, and it's much easier to just manage it with what you know rather than try and orchestrate it like you do in production. So maybe there's good reason for it.
The biggest drawback for using Kubernetes in development is that every time you want to make a change to something, you've got to recreate your image. So you've got to create a new image and then deploy that. So that's the bit that slows you down. Where obviously when we're developing using Docker, we're making changes that are directly affecting what's on the container that's currently running. Kubernetes, you'd have to redeploy that image again. So it's a slower process.
The images do rebuild very quickly, but nonetheless, it's still, you make a change to a model, you have to an intermediary step before you can run it in an environment. So I don't think there's any advantages, but it's certainly interesting.
There's tools out there to do it, and it's slowly getting there, but I think it'll be a little while before we're at the point where we would do it all our development in Kubernetes and not use Docker at all.
Okay, cheers.
Sure. So back to the demo. As you can see, the DB is now running and our 3 replicas are running. So all we need to do now is to run the setup on one of the containers. So ctl exec -- bin setup. The suspense. Okay, sweet. So now, to our cluster. So if you look in the ingress tab, these services and ingress, so that's our load balancer. And this is the IP that load balancer is currently at. It's got port 80 there. So hopefully, just doing that. Just a refresh. There you go. And that's works. So just to finish, round out, a couple of places that maybe if you're interested in learning more, I'll check out the work of Nigel Poulton. His Kubernetes deep dive on A Cloud Guru is excellent. It's largely inspired me to do this talk. He's also got 2 books, one on Kubernetes and one on Docker, both are really good. There's also a YouTube channel, Kubernetes This Month, which again are in the references. We've kind of covered questions. Is there any more questions just while? No? Cool. Those are my references. And it's finished.
Thanks, Wakey. That was great.
Yeah,
thank you.
Very good.